So in this session, you will learn about this spectrum and the technology behind dynamic spectrum sharing. So ano yung dynamic spectrum sharing? Because when you implement LTE and 5G in one equipment, so you will be you have the option to use the dynamic spectrum sharing. So let's start with the topics no na prepare ko for you. So meron tayong papahapyaw lang natin yung introduction sa RAN. So babalikan lang natin. And then what is spectrum? And then what is a dynamic spectrum sharing? And then we'll talk about the Open RAN technical priorities. And then we'll zoom in sa Open RAN and DSS use case. And then we will finish it by key learning points. Okay. Okay. So as we already know, the radio access network is the one that gives us the mobile coverage. So siya yung nagbibigay sa atin ng signal. Ano ba akong video? Yan. Wala pala akong video. Yan. Siya yung nagbibigay sa atin ng signal. Okay? So kaya ka nagkakaroon ng 2G, 3G dahil sa ano, dahil sa spectrum na yan. So frequency na ginagamit. And then for a typical person, minsan medyo mahirap intindihin yung ano, yung spectrum o yung frequency because it's an invisible resource. Invisible, not seen by the naked eye, and hindi siya naaamoy, hindi siya nahahawakan. Okay? Kaya it's sometimes difficult to comprehend yung concept ng electromagnetic energy. But in this session, so we hope we can discuss it with you. So siya yung ginagamit ng mga radio access network to connect our mobile equipment or the user equipment papunta sa radio access network. Okay, so kaya tayo nagkakaroon ng mga different signals, no? Different signal strength. Yan. And pagka tinignan natin saan natin ginagamit yung spectrum, so in particular, sa part ng wireless telecommunications network, dito natin siya ginagamit. Okay, itong air interface na to. Because there's a few discussion dun sa radio access network na course. So kinakailangan mag-deep dive tayo papunta dito sa radio frequency. Itong interface na yan. So paano siya gumagana? Okay, so from RAN going to the user terminals. So meron tayong radio frequency ginagamit. Okay? So, pag-usapan natin what is a spectrum. Yan. So, when we talk about spectrum, or the spectrum is the fundamental asset that provides wireless connectivity. So, it is an invisible electromagnetic wave generated by radio transmitting devices. Okay, so this is a disturbance no sa natin space. So spectrum is about yung frequency measured in hertz. So hertz ang ating unit of measurement sa spectrum, sa frequency. Kaya most of the time nakakarinig kayo ng frequency ng AM. For example, 666 kilohertz, no? So hertz yun, no? So ang basic unit is the hertz. And then, for example, nakikinig kayo ng FM radio. Meron tayong 101.9 Yes FM. So, that is 101.9 megahertz. Okay, so mas mataas yung frequency ng FM compared kay AM. And the same thing goes with the television. So, meron siyang 54 megahertz sa VHF. And then going to the UHF. And then pagdating sa wireless telecommunications, meron din tayo iba't ibang mga frequencies, no, na pag-uusapan natin later on. So itong mga frequencies na to, operators acquire a license to use the specific frequencies for a given period of time. So in return for paying an annual fee, which is ang tawag natin is the spectrum users fee or the USF. The SUF, SUF yan. Spectrum Users Fee. Okay? So, ibig sabihin, nagbabayad sila dyan so para maging exclusive sa kanila, no, yung kanilang frequency. and then no other entity can use that. If somebody use that frequency, that is considered illegal. Okay, so the NTC will confiscate your equipment because you are not allowed to transmit on that certain frequency band. Kaya yung mga boosters na nakikita nyo na nagpapalakas ng signal sa loob ng bahay, that is considered illegal unless the operators install it inside your house or inside your home. But if you are the one who initiated the installation of that booster, or some contractor offered you to install a booster inside your house to increase the signal level ng cellular signal sa loob ng bahay mo, that is considered illegal because the frequency used by your equipment is not licensed to your name, no? Under your name. It is licensed to the operators or the mobile telecommunications operator here in the Philippines. Okay, so the licenses usually are 10 to 20 years in duration. Yan yung pagkakaiba ng frequency ng cellular sa frequency ng Wi-Fi. Because Wi-Fi is under the free frequency, no? In the industrial, scientific, and medical frequencies. Katulad ng Bluetooth. So you don't need to go to NTC and license the frequency ng Bluetooth or ng Wi-Fi sa isang entity because it's a free. Everybody can use that. So if it's free and everybody can use it, so you don't have any control, especially in the interference. And alam natin, kapag may interference sa isang lugar, ang nangyayari is the quality is degraded. Is it in a simple analogy, for example, nagkasalita ka and then may sumasabay sa'yo nagkasalita, sabay kayo nagsasalita. No? So it's interfering. And the cause of interference is mutual. It's not only one way. So if somebody is interfering my system, at the same time, my system is also interfering with their system. So kaya may mga, nakikita kayo, may mga Wi-Fi na areas na magkaibang entity ang nag-install and then hindi na plano ng maigi yung frequency. So medyo pangit ang performance ng Wi-Fi. Okay, so yun ang yun ang yun ang ang main differences ng frequency use ng Wi-Fi at ng mga cellular. So cellular, meron tayong exclusivity. Sa atin talaga yan, no? Sa operator talaga. Naka-allocate yan. Okay? So sino-sino yung mga gumagamit ng mga spectrum, no? Sino-sino nandyan? So ang spectrum is malaki. So mula sa extremely low frequency hanggang sa extremely high frequency, yung mga cosmic frequencies, no? Cosmic rays, yan. So ang spectrum contains all frequencies in the universe. Pare-parehas tayo ng frequency sa buong universe. Ang iniiwasan lang talaga natin sa spectrum is magkaroon tayo ng overlapping on the same area na paggamit ng frequency or spectrum para maiwasan natin yung interference. And it is used by different types of services like satellite, mobile, TV, and emergency services. Anything that is operating at wireless. So gumagamit yan spectrum or frequency. And then it goes from very low frequency and extremely high frequency. Okay, so may mga frequencies na naririnig tayo. Okay, mayroong mga frequencies na hindi natin naririnig. And then may mga frequencies na hindi natin nakikita. So the only frequency that we can see is the visible light. No, nandito yun sa nandito siya sa spectrum na to, sa visible light na to. Yan, ito lang yung nakikita natin. So meaning light is a type of electromagnetic energy na tinatransmit mula sa, for example, araw or sun going to earth. Okay, and the speed of light is 3 times 10 to the 8 meter per second, which is the same as the electromagnetic energy. Okay, kaya kapag sumikat ang araw, not necessarily sabi mo siyang nakikita, no, dahil sa distance, no, from the sun. the distance of sun to the earth, it takes 8 minutes before we see the sun. So kaya nga sinasabi kapag sumabog yung araw, mga 8 minutes pa tayo maghihintay. Okay, bago natin makita. Because it takes time, no, for light to travel, no. So in a huge distance between Earth and the sun. So gano'n, no. Pero kapag sa Earth mo siya in-apply, because the speed, hindi natin nakikita, no, yung lag or delay. Okay. Ayan. So sa spectrum din na ginagamit natin, it is categorized as non-ionizing radiation and ionizing radiations. Ito. So when we say ionizing radiations, matataas ang electromagnetic energy yan. Okay, so gagamit ka ng Planck's constant, no, para ma-compute mo yung electromagnetic energy. And then sa sobrang lakas niyan, in terms of penetration, and then kapag kabubanggayan sa molecules or sa atom ng katawan ng tao, it can kick an electron. So, if there's a movement of electron or kicking of electron in an atom, di ba? Kakaroon tayo ng mga iba't ibang bonds. So, it could go to the mga radical elements, no? Kaya minsan itong mga frequencies na to, from ultraviolet going to X-ray, cosmic ray, it causes certain diseases na sa mga tao kasi nababago yung molecular structure natin, yung DNA, yung natin, ano. Kaya nagkakaroon yung iba ng mga cancerous, di ba? Kaya pero ang ginagawa kasi ng iba ay they correlate it also dun sa mga non-ionizing dito. Kaya minsan may mga naririnig kayong mga myth, no, or mga urban legend na sobrang lakas sa sobrang lakas daw ng signal, kakasakit yung mga tao, nalalanta yung mga pananim, okay, namamayat yung mga baka. So which is not scientifically proven, no. Ito proven to kasi kaya nga minsan kapag magpapa-X-ray tayo, no, so tinatanong kung ikaw ay pregnant or pang ilang X-ray mo na. So maximum yata is 2 months twice a year, no, yung papagawa ng X-ray lalo na kapag nasa mga vital organs mo. Ayan. So good thing here is yung mga frequencies na ginagamit ng ating mga devices are considered non-ionizing. Okay, it does not create any kicking of electron do sa ating sa atomic level kasi mababa lang yung kanyang electromagnetic energy. And the good thing also here is that yung power level niyan is regulated and managed by a certain organization called ICNIRP, no, or International Commissions for Non-Ionizing Radiation. Kapag tinignan niyo yung mga telepono niyo, meron yung logo ng ICNIRP. Meaning si ICNRP is a group of biologists, physicists, okay, chemists, okay, at mga scientists na nag-i-study ng effect ng non-ionizing radiations sa health ng tao. And after decades of study, no, sa ICNRP, nakita nila na ang only effect ng electromagnetic energy or yung frequency sa tao sa non-ionizing is the heating effect, no. Pag pumunta kayo sa website ng ICNIRP, just type it in like this. So ICNIRP, so International Commission on Non-Ionizing Radiation. Yan yung kanilang website. So if you visit the ICNRP, ayan, so makikita nyo lahat ng mga frequencies na ginagamit, no. So from 5G, so if you have some research na gagawin sa inyong school and then you want to have some good reference about the frequencies or spectrum and then yung effect nito para masagot nyo yung mga questions about the health effects ng cell sites or ng wireless telecommunication system, punta lang kayo sa ICNRP, sa International Commission on Non-Ionizing Radiation. And then, pwede nyo hanapin kung anong frequency yung inyong gagamitin. Okay, so In our case, dun sa ating mga cell sites, ang gamit natin ngayon is within the 100 kilohertz up to 300 gigahertz. Yan. Okay. So if you click here, pag pumunta kayo dyan sa ICNRP, so andito yung kanilang meron silang video and then you will see yung effect on the body and health implications. Yan. Okay, so makikita niyo yung health and effect, no? So sabi nila dito is after several decades of RF, EMF, no? EMF research on numerous potential health effects, ang only substantiated effect of RF, you know, RF EMF exposure na relevant sa human health and safety ay heating of exposed tissues. So medyo mainit. No? So bakit siya nag-iinit? So nag-iinit siya dahil yung RF EMF fields can penetrate into the body, okay, and can cause vibrations, no, of charge or polar molecules inside. And thus, this is in friction and produces heat. Yan. Kaya ang minomonitor nila dyan is talaga bang talaga bang matakas yung power. Kaya meron silang requirement, no, dun sa inyong telepono at sa ating mga transmitters. Yan. So more of this makikita niyo yan sa marami tayong mga reference dito. Andiyan yung 5G, mobile phones, and then base stations. So you can also see ano yung regulated output power ng mga cell sites. Okay, kaya kapag may mga nagtatanong sa akin dito, itong binibigay ko sa kanila. So they can also do extensive research on this para at least mas matibay, no, yung inyong um, stand pagdating sa non-ionizing radiation. Kasi kapag ka nagkatayo ng mga cell sites sa probinsya, yan ang concern nila, no? So it's either cell site or a typical traditional run or an open run. Eh, parehas lang yan, ano? Parehas lang sila ng frequency gagamitin din, ano? Kaya kapag gumamit tayo ng traditional run or open run, hindi siya magkaibang frequency. Parehas tayo ng frequency gagamitin. Wala tayong ibang pamimilian na frequencies. Okay? So ayan yung ating spectrum. So paano ba na-discover yung ang electromagnetic waves? So ang electromagnetic waves ay na-discover ng pinakalolo ng mga radio access network engineers or mga RAN engineers. Nagsimula ito noong dumating yung isang Scottish scientist, noong 1879. So mas kilala siya sa tawag na James Clerk Maxwell. Yeah. So si James Clerk Maxwell is notable on his achievement to formulate yung classical theory of electromagnetic radiation. So ano yung classical theory of electromagnetic radiation? So pinagsama-sama niya, no, yung concept ng electricity, ng magnetism, and light, no, as a different manifestations of the same phenomenon. Yeah. So dito na formulate niya rin yung Maxwell's equations, itong apat na equations na yan, which is very familiar with the ECE students kapag pinag-usapan nila yung electromagnetics. Favorite nila yan, electromagnetics. Gustong-gusto nila yan. Excited na excited sila kapag yan ang topic. Okay. So Maxwell's equations for electromagnetism, tinawag yung second great unification in physics. Okay. Kasi yung una is yung kay Isaac Newton. Okay? So, nung 1865, particularly, nag-publish si James Clerk Maxwell ng isang article about a dynamical theory of electromagnetic field. Yan. So, dinedemonstrate nito that an electric and magnetic field travel through space as waves, no, moving at the speed of light. So yun yung pinaka-concept ng niya, ng kanyang paper, no. So pinopropose niya rin diyan na that light is undulated in the same medium na nagko-cause ng electric and magnetic phenomena. So yung unification ng light and electrical phenomena, ito yung nag-led sa kanyang prediction, okay, of the existence of radio waves. So meron na pala siyang prediction noon, no? Naiisip na ni James Clerk Maxwell na there is some type of wave, no, which is electromagnetic na existing, no. But ang naging problema ni James Clerk Maxwell that time, he was not able to demonstrate yung presence ng radio waves. Okay, so nasa equation pa lang siya, nasa theory. Okay, nasa theory. Until dumating yung isa nating lolo nung um, mula 1857 hanggang 1894 na ang pangalan ay si Heinrich Rudolf Hertz. Yan. So siya naman ay isang German physicist na kauna-unahang nag-conclusively prove ng existence ng electromagnetic waves na pinredict ni James Clerk Maxwell. No? Kaya yung unit of frequency or yung cycles per second was named under Heinrich Rudolf Hertz, so, in his honor. So ganito yung ginawa niyang ganito yung ginawa niyang experiment, no. Ayan, so meron siyang high voltage na coil dito, and then meron siyang battery. Okay, meron siyang battery, high voltage coil, and then magkakaroon siya ng spark dito, no. Yan, meron yung gap. Yan. And then ang mangyari kapag meron siyang tinransmit, itong receiver na to will cause a spark din, no. Ibig sabihin, meron transmission ng energy. So yun ang ginawang experiment ni Heinrich Rudolf Hertz. So ito yung illustration nung ginawa niya, no. Yan, no. Yan. So meron siya tinatawag na Leyden jar, no, na into one of the coils, no, na na-produce. So meron siya ditong open loop antenna, no. So ito yung proof na nagkaroon siya ng transmission, no, from the spark here tapos nag-ilaw, no, yung LED diyan. Kasi ito dalawang capacitor. Yan. So ganyan yung ginawa niyang experiment. So based sa details ng kanyang experiment, yung kanyang antenna was excited by a pulse of high voltage about 30 kilovolts. Yan, no. 30 kilovolts yung pinaka voltahe niya, no. And then ang na-produce niyang radio waves diyan is under the very high frequency range. Yan, VHF. Okay? Yeah, so nanalo siya diyan ng prize. Hindi ko alam anong prize nung panalo niya. Okay. So ito yung experiment ni Heinrich Rudolf Hertz, no. Okay. So balikan natin yung concept ng wave. So paano ba napoproduce, no, ang electromagnetic wave? So pagka pinuntahan natin yung waves actually are traveling around you all of the time. Kasama din yung light and yung sound. Kaya minsan makita nyo yung sound waves, no? But unfortunately, you cannot see yung mga traveling waves. So to understand yung wave, we'll need to have a method like this to show, no, yung how we can move the rope and then transfer the energy, which is the kinetic energy, moves across it, no? So when we define wave is a disturbance that transfers energy as it travels through a medium. Yeah, so disturbance siya, no? So in this scenario, the rope is considered as the medium or yung substance natin, made of matter that carries the wave. So it's very important to understand that the wave is a disturbance that transfers energy as it travels through a medium. Ibig sabihin, the medium, yung rope, moves because of the wave. Okay? Because of the wave, but it is not the wave. Kasi minsan nakita nila, ito yung ano, no? Ito yung wave. Pero that's only the medium. Okay? The wave is the disturbance that transfers the energy. So, not necessarily yung rope natin, yun din yung wave. Okay? Ayan. So, let's see ano yung mga types of um, mga terms na kailangan nating maintindihan, no, when we talk about waves. So, let's talk about periodic motion. Yan. So, from here, ano yung makikita nating periodic dyan, no? So, for example, letter A, letter B, or letter C. Alin dito ang periodic? Wala. Okay. So when something is periodic, okay, at a specific time, it repeats, no, at specific time intervals or periods. Yan. So, ibig sabihin nauulit siya, no? Nauulit. So, yung pag-travel nitong airplane na to from one place to another is not periodic, no? Pero itong pendulum, nakita mo, it's periodic kasi nare-repeat siya, no, at a specific time interval. At ito ring pag-ikot ng moon around the earth is also considered periodic. Okay? So periodic yung dalawang yan. As long as meron siyang repetition at a specific time intervals. So when we talk about waves naman, okay? When we talk about waves, these are the waves that are considered periodic. Itong letter B, okay? Itong letter D, at itong letter E. Yan. Although ito, they are moving, but you cannot see any pattern, no? Yan. So, unlike this, there is a periodicity, no, ng movement ng mga waves natin. So, a wave pulse is a single disturbance, but a periodic wave will continually repeat at regular time intervals. Okay? And then next term is the oscillation. Yan. So, oscillation. So, oscillation is the back and forth, no, pattern of motion between two states about a central position. So, kung may central position ka, it's a back and forth, no, up and down or left or right na movement. Kaya dito, nakita natin, the pendulum is considered an oscillatory motion or oscillating motion. Okay. So, pag pinagsama natin yan, yung oscillatory and periodic motion, we can see that this is a periodic and oscillatory, but this one is only periodic kasi hindi naman siya bumabalik, no? So, this is what we are looking at when we are talking about waves. It should be periodic and oscillating wave. Okay, so meron siyang up and down at nauulit siya at specific time interval. So now we will move on sa wave anatomy. Yan. So yung wave anatomy, so meron tayong sample dito ng sine wave. So when we look at the sine wave, so we have the amplitude. Okay? Meron tayong amplitude. So this is the highest, no, maximum displacement from a wave's rest position. Okay. So amplitude. So either sa taas or sa baba. Okay. So kapag tinignan natin yung taas, this is what we call the crest. No, on the positive amplitude, this is the crest. And sa baba naman is the throw. So ito yung negative amplitude natin sa throw. And then the difference between crest to crest or throw to throw, it's what we call the wavelength. Yun yung haba, no, ng ano natin. And then you also have the direction of the travel. Kaya kapag nakita natin, kung meron tayong certain speed, yung fixed yung speed niyan, and then we have the wavelength, we can calculate actually the frequency. Okay, so the frequency would be the speed of light divided by the length. No? So that is in hertz. And, or we can transpose yung ano no, yung ating equation. So the wavelength will be equal to the speed of light divided by the frequency, no, in hertz. Yeah. So now let's define what is frequency. So frequency is the number of completed wavelengths that pass a point in a certain amount of time. So it is often represented in units per second or hertz. Okay, so kung ilang beses siya dumadaan ano, from crest to crest at a certain period of time. So per second. So kung dumaan siya ng dalawang crest in 1 second, so that is or isang wavelength sa isang second, so that is 1 hertz. Okay, so kapag dumaan siya ng 1 million times in 1 second, that is 1 megahertz. Okay, so ganun yung ano natin, no? So kung gaano kabilis yung cycle na dumadaan on a certain on a unit per second. So makikita natin na kapag ka ang wave, if we will compare it sa mga vehicles, so for a long vehicle like this, yung mga trucks natin, it takes long time for them, no, to complete one wavelength. Kaya yung mga frequency niyan is mabababa. And then yung ating mga kotse, which is a smaller wavelength, okay? So mas ano na to, no, mas mabibilis, no, mas matataas yung frequency niyan. So when we are looking at this at this illustration, we can see that we can have a conclusion that wavelength increases when the frequency increases. Okay, so also if you are using the formula, so ganun ang mangyayari sa kanya, no? So kapag ka tumaas yung kapag ka bumaba yung frequency natin, ang mangyayari dito is tataas yung ating wavelength, no? Yan, so mas ano siya, no? So inversely proportional yung ating wavelength at yung ating frequency. Okay? So magkabaligtad siya. So ganoon din ang nangyayari, no? Kapag tinignan natin yung iba't ibang frequency ng mga cellular technologies na ginagamit natin. So there are different frequencies from 450, 800, 900, 1 gig, 1800, okay? So these are the different frequencies na ginagamit din natin sa mga cellular technologies. So nakikita natin that the higher the frequency, okay, mas bumababa yung ating wavelength. So anong effect niyan, no? Yung pagbaba ng wavelength na yan. So yung pagbaba ng wavelength na yan is as an effect lalo na sa size ng antenna natin. Okay, so most of the time kapag nakakita kayo ng mga antennas, no, so isang um, rectangular shape yan, no, na na form factor. And then nasa loob niya yung mga antenna elements. Yan, may mga antenna elements yan. Okay? Yan. So in this example, meron tayong 6 antenna elements. And then for this to function as a directional antenna, so kinakailangan ang ating distance is half of the wavelength. Yan, half nito. So ibig sabihin yung distance separation ng mga antenna elements natin is half the wavelength. Okay? So kapag mataas ang frequencies natin, yung mga antenna elements natin can be dikit-dikit, no? Pwede magdikit-dikit yan kasi maliit lang yung spacing na kailangan natin. However, kapag bumaba yung antenna mo, okay, ang mangyayari sa wavelength mo is lalaki, no? So there's a possibility na nandito yan. So malaki yung gap, no, nung iyong antenna elements. Kapag malaki yung gap nila to satisfy yung directivity ng antenna mo, ang nangyayari sa antenna mo is lumalaki yung design physically. Kaya may mga makikita kayong mga antennas, okay, may mga makikita kayong mga antennas like this na malalaki at may mga maliliit, no, na mga antennas. Kasi this satisfies yung physics ng frequency at ng wavelength. Okay? So pag nakakita ka ng malaking antenna like this, so there's a possibility na gumagamit to ng lower frequency compared dito sa antenna na to at sa antenna na to. Kaya yun yung sagot sa why there are antennas na magkakaiba yung size. So, isang major na reason is yung frequency range na pinaggagamitan natin. Okay, so that's a possibility na mababa yung frequency nito compared sa frequency nito. But the only thing that will conclude yung ating theory is to check the specifications ng antenna. Di ba? Yun ang kailangan natin gawin para makonclude natin talaga. Okay? Ayan. So, ito yung ating antennas, no? O yung mga frequencies natin. Pero gaano ba ka-importante ang frequency sa operator, no? So, ang frequency or spectrum is just like a highway. Okay, parang kalsada. When we say kalsada, if you have one transmitter here, so para ka may toll gate dito na transmitter, and then another transmitter dito papunta sa kabilang toll gate. Okay? So, yung frequency is parang kalsada. Yan. So, para siyang kalsada. The bigger the kalsada is the more vehicles that can pass through, di ba? Or can travel. Yan. So, mas maraming vehicles, mas maraming taong pwedeng i-transfer. So, mas marami kang information na pwedeng i-transmit at i-receive from one toll gate to another because of your frequency. Okay? And then, merong mga frequencies tayo or kalsada na maiikli. Okay? Maiikli, pero matataba. Okay? May mga ganyan tayong kalsada. Okay? Teka lang. Isin natin ito. So, meron tayong mga kalsadang maikli. And then, meron tayong mga kalsadang mga mga maninipis lang. Ayan. Sa mga maninipis na ganyan, meron tayong mga kalsada na matataba. Okay? So, yun yung bandwidth na sinasabi natin. And then, meron tayong mga kalsadang mga maliliit lang. Pero, jumbo, no? Jumbo, no? Yung bandwidth niyan. So, think of the frequencies or spectrum as highways. Kaya importante yan sa mga operator. And then, if the highway is exclusively for smart users or globe users, ibig sabihin, itong mga sasakyan na yan, smart users lang yan. Itong mga globe users, di pwedeng gumamit yan. Kasi nagbabayad sila ng kalsada nila, no? So, that is considered as as a license frequency sa kanila. But if this is not licensed and then everybody can use it, even different people, walang control sa spectrum, so makita mo minsan magko-congest yan. Okay. So, di ba minsan kapag may kalsada, nakita mo merong specific na lane yung bus. Okay, so that one we can consider as license, no? Sa mga bus lang. Hindi ka pwedeng pumasok doon. If you try to go there, you will be punished, no? Or you will have a penalty. Yeah. So ganun ang concept natin sa frequency, no? Or the spectrum. Okay? So, marami tayong types of frequency. Meron tayong high band. Okay, ito yung mga matataas ang frequency. Meron tayong mid band. And then meron tayong low band frequencies. Okay, so mamaya isa-isahin natin yung mga yan. So the important thing sa kung bakit importante yung mga reasons, no, for the spectrum to be considered as a key asset of mobile operators, it's because it defines how much capacity. So mas marami kang kalsada, mas marami kang sasakyan na pwedeng padaanin, which will consider sa capacity. Okay, kapag manipis yung kalsada mo, medyo traffic dyan, medyo congested dyan. So, ganun ang concept ng spectrum. when we compare it sa mga roads and highways. And at the same time, it defines how wide yung coverage. So, gaano kahaba yung kalsada mo? Hanggang saan yan aabot? So, hanggang Valenzuela ba? Going to Dau? Okay? Or from Cebu City going to Lapu-Lapu City? Yan, no? Or from Davao going to Cagayan de Oro? Yan. So, it defines, no? Gaano kalayo nararating. And then, gaano kalapad. Kasi makita mo, yung mga roads natin sa NCR, nasisikip, no? Kaya, what they do, they add capacity. So, anong ginagawa nila sa capacity? Nag-a-add sila ng mga additional skyway, okay? Minsan may mga um, subway ba tawag natin doon? May subway tayo, no? Subway, no? Pero may mga ano tayo, may mga sa ilalim din tayo, no? So, to increase the capacity. Yan. So, consider it as a new frequency. Kaya may makikita kayong mga cell sites na may 900 megahertz, may 1800 megahertz, may 2100, may 3500. So, ang ibig sabihin lang nun, marami tayong kalsadang pinagpatong-patong, no? So meron kang kalsada sa taas, meron kang kalsada dito, okay, meron kang kalsada sa taas ulit, no? Yan, meron kang skyway. Yan. So because we are maximizing yung space, no? So para mas tumaas yung capacity ng cell site, nagdadagdag tayo ng maraming frequency. Yan. Kaya importante yung frequency. Okay? So, meron ding importance ang pagpili ng frequency. Okay? Bakit importante ang pagpili ng frequency? Or sa start pa lang ng pag-deploy ng isang radio access network. Specifically kung ang isang operator ay magiging open run, anong frequency ang gagamitin niya? So kung merong isang bagong entity na itatayo din sa Pilipinas, unang-una nilang pag-uusapan, anong frequency ang gagamitin natin? And then later on, anong mga equipment? Okay? Because the frequency will define yung isa sa mga success, no, ng operator. For example, meron tayong ano, no, ito yung side view, no, importance ng frequency selection. If you have a cell site, okay, ito yung top view natin. Ito yung side view, ito yung top view. So if you have a cell site, may 2100 ka, so ang top view niyan, ganyan. So ito yung side view. Okay, kung nandito ka nakatayo, may signal ka. Nandito ka nakatayo, may signal ka. Yun ang ibig sabihin dyan. And then, ito yung 700 megahertz. So makikita nyo, yung 700 megahertz has a wider coverage. So kung nandito si Richard, so nandito siya. So makikita natin, co-covered pa rin siya. So may mga frequencies na magko-cover sa'yo at may mga frequencies na not enough, no, para ma-cover ka. So that is because of the power and also yung physics ng frequency. Ibig sabihin, kapag ka nag-travel yan through space, ang nangyayari, na-absorb ng mga molecules sa atmosphere and then nawawala yung power, no, na nauubos yung power. Okay? So meron pa tayong mga tinatawag na diffractions, okay, may mga nagre-reflect, okay? So kaya yung ating power using that kind of frequency is diminished. Okay? So kapag tinignan niyo yung mga tao, so may mga tao na you can cover by two frequencies, itong area na to. So you can cover this by two frequencies and then the outer one will be covered by only one frequency, like the 700 megahertz. Okay? So that is in terms of coverage. Now in terms of penetration, so yung mga higher frequencies natin get reflected from walls and have poor penetration. So ito yung ano nila, no? Ito yung kanilang performance, no? Kapag bumabangga sila sa mga walls, so hindi siya gano'n nagpe-penetrate. Unlike yung mga high frequencies natin, ay yung mga low frequencies natin like 900, 700 megahertz, they can get attenuated from walls but still can penetrate. Yan, nakakatagos sila. Kaya yung mga 700, 900, pagdating sa selection ng frequencies, ito yung ginagamit natin for coverage layer. So it's either sa rural or sa urban, pero sa urban, pang coverage layer natin yan. Pang tagos sa mga bahay. Okay? So you can see, ito yung ating types of frequencies. Meron tayong high band, mid band, at low band. Okay? So yung mga lower frequency, so the signal travels further. Mas malayo yung nararating yan. And then yung mga lower frequencies, ibig sabihin, we need fewer base stations. Mas konting cell site ang kailangan natin. Right? Kasi nga, malayo yung nararating niya, so kaya niya mag-cover na mas malayo. So before we need to put another cell site, it takes more distance before we do it, before we build another one. Okay, so yun yung pinaka-advantage ng 700 or ng 900. So mas ano siya, mas malayo nararating niya. So mas tipid siya, essentially. So kung meron kang kinakailangan na isang area na gusto mong lagyan ng open run signal, tapos kinakailangan mo lang ng, kapag gumamit ka ng 2100, kinakailangan mo ng dalawa, okay, para ma-cover siya. So for example, no, ang isang cell site is 1 million or 5 million pesos. So that is equivalent to 10 million pesos. However, kapag ka nagtayo ka ng 700, isang cell site lang, kailan mo na yan. So, nakatipid ka ng 5 million pesos. Okay, so ganun yung pagpili ng frequency because it has an impact sa cost of implementation. So, mas meron kang, may mga combinations ka ng frequencies ng low band, mid band, at high band, much better because you can have different combinations, no? Depending sa need ng mga subscribers mo. Okay? And when you look at this, yung higher frequency have most of the time bigger bandwidth. Kaya yung mga higher frequencies like this ay ginagamit natin for mga hotspot areas or yung concentration ng mga tao marami. Okay, so mas maraming tao. So sa mga urban areas, dinideploy natin yung mga high band na, mga high frequencies na yan. Okay? So, kumpara natin yung 1 millimeter wave, kung narinig nyo na yung millimeter wave, i-compare natin, no, yung coverage and capacity. So, meron tayong antenna, okay, meron tayong cell site dito. So, the cell site could be a traditional or open run. Okay, so if we're talking about RF, it doesn't matter if it's open or traditional run. So, if we're using a 28 gigahertz, no, 28 gigahertz, so mataas ng frequency yan, your capacity could reach up to 5 gigabit per second. Ganyang kalaki yan, ano? So, malapad masyado yan. 8 gigabit per second. So, it could be used sa hotspot capacity and mga fixed wireless. And then, if we are going to use yung 3,500 megahertz or 35 megahertz, you can see, no, na optimal yung kanyang coverage. And then, yung capacity din niya is sufficient to enough to give us up to 2 gigabit per second. So, maganda yung application for urban capacity with massive MIMO antenna. And then, yung mga 700 megahertz na malalayo ang nararating, ang trade-off lang yan is medyo mababa yung kanyang bandwidth compared kay 35 at kay 28 gig. Kaya ang throughput na nabibigay niyan is umaabot lang ng 0.2 or 200 Mbps. Pero ang advantage niyan is mas malayo ang nararating niyan. And then, nagpe-penetrate yan sa loob ng mga bahay. Okay, so ngayon maiisip niyo na, kapag ka mga rural areas pala, no, I can use mga 700 megahertz para ma-cover ko sila, no, with less sites. So mas optimal yung cost. And then yung coverage is also good. Okay? So ito yung frequency band, no? Coverage versus capacity. At for example, no, meron tayong mga dineploy sa Pilipinas like yung 3500 megahertz. Although hindi natin ito nami-meet pa, no? Pero na-meet natin is 1 gigabit per second. So this is the sample of 1 gigabit per second. So this was taken sa Clark. Okay, can you see this? So meron tayong 1,000 Mbps, 1,004 o 1,012 Mbps. And yung ating upload ay medyo mababa lang yung configuration niya, ano? Kasi TDD siya. So nasa 79 Mbps. So it's a good, no, indicator. So ang ginamit na frequency dito ay 3.5 gigahertz. And then ang bandwidth niyan is nasa 60 megahertz, ganun kalapad. So meaning, for you to be able to have a 5G technology that can give you 1 gigabit per second, at least meron kang 60 megahertz na bandwidth. Okay, so kaya importante 'yon. Kaya yung mga testings na kung ano yung gusto nating throughput na makuha, so meron yang requirement na bandwidth. Gaano karaming minimum bandwidth para ma-meet mo yung iyong target na throughput. Okay, so ito yung signal level na yan. So once na nagtayo na kayo ng Open RAN, so you will also do something like this kasi you need to test yung performance ng Open RAN, no, if it's working as planned or not. And then you need to have a test phone, no, like this, no. Itong test phone na to is special type of phones na ginagamit for measuring yung air interface. So you can measure yung signal to interference noise ratio, yung signal level ng reference signal, reference power, ano yung quality, okay? Sino yung cell site na nag-serve sa'yo? Okay, so ito yung ano yan, ito yung pang-test na yan. And then it can also test 5G, LTE, or even Wi-Fi. Yeah, so it depends, no? Kung ano yung gusto mong i-test. Yeah. And then meron pang ibang mga test tools to measure. For example, no, kapag ka nag-speed test ka pala, no, anong nangyayari sa telepono mo? So it looks something like this. So this phone is connected to a laptop, and then yung laptop is meron siyang software, we call it the Pilot Pioneer. So it's a proprietary software na ginagamit to measure yung air interface, no? So as I mentioned to you sa 5G, that when you see a 5G logo sa inyong telepono like this, your phone is connected sa LTE at sa 5G, sa LTE and sa 5G ng sabay. You can see your phone can measure the same time, no, connected actually sa LTE at sa 5G ng sabay. Although there is a difference in signal level and signal quality, you can see yung performance pa rin umaabot hanggang 512 Mbps. Okay? And then you can see here, yung mga parameters ng frequency, band 78 siya. So, ibig sabihin, that is a 3.5 gigahertz. Yung bandwidth niya is 60 megahertz. Okay? Yung kanyang carrier spacing is 30 kilohertz. And then yung modulation is umaabot ng 256 QAM sa downlink at 64 QAM sa uplink. So, you will see yung impact, no, ng mga yan. So, ito rin ay gumagamit ng massive MIMO antenna. Kaya na-reach niya doon sa previous testing, yung 1 gigabit per second. Okay? Yan. So, that is isang gamit, no, in terms of the capacity. So why it's important for us to have a sufficient bandwidth. So this is to get the throughput that we need. So that's the main factors bakit natin kailangan ng bandwidth. Main reason. And in terms of coverage naman, in terms of simulation, you can see the simulation I did for a certain area, no, which has a 2.7 kilometer by 3.2 kilometer. So I used one cell site with different frequencies. So pare-parehas siya ng configuration, parehas ng antenna height with 20 meter, and then mechanical tilt of 2 degrees, and then electrical tilt of 2 degrees. No? You can see here sa right side, I used a frequency of 900 megahertz. And then on the further right, I used a frequency of 1800 megahertz. Para mas madali nyo makita, you just check the blue color. So yung blue color, this is the signal where you have full bars. No? Malaki yung mataas yung signal level mo. Pag tinignan mo yung telepono mo, full bar ka. So makita mo no, yung difference ng coverage of a 900 megahertz and an 1800 megahertz. So this also concludes na sa isang area, you could only need one cell site to cover it using 900 megahertz. But if you use 1800 megahertz in terms of coverage, you can use probably 2 sites or 3 sites compared sa 900 megahertz. So ito yung sinasabi ko kanina na mas nakakatipid ka in terms of coverage. So, but coverage is not always as important as capacity. Because ang mangyari, kung mayroon kang coverage and then kulang ka sa capacity, magrereklamo yung mga subscribers mo. Dahil bakit sila may signal pero hindi sila makatawag. So, ibig sabihin, congested yung site mo. So, ibig sabihin, yung capacity is not enough. No? So, yung design is not good. So, kaya most of the time, makikita nyo, sa isang cell site, pinagsasama yung 1800, 900, 700. So, this is to balance yung capacity and coverage ng cell site. Para may sufficient coverage sila, and at the same time, may sufficient capacity sila. Okay? Yan. So, sa Pilipinas, sir, ano po ba mga ginagamit na frequencies? Sa Pilipinas, meron tayong 450 megahertz. Okay? Meron tayong 700 megahertz, 850 megahertz, 900, 1800, 1900, 2000, 2100. So you can see, no, yung the way we pronounce it, it's like a American pronunciation. 2300, 2500, no? No, bihira sa RF yung nagsasalita ng 2500 megahertz or 3300 megahertz or 3500 megahertz. Or most of the time, ang banggit is 3500 or 450, 1900. So makikita nyo, yung mga red ones are the FDD or the frequency division duplex. And then yung mga blue frequencies are under the TDD or the time division duplex. So ano pagkakaiba nila? So meron tayong mga FDD frequencies. Okay, so meaning yung inyong telepono is communicating sa cell site on a different frequency band. And yung cell site pababa ng inyong cellphone ay nagko-communicate at a different frequency. So magkaiba sila ng frequency. Okay? For example, kung ito ay 1920, ito ay 2110 megahertz. Yeah. So ganyan yung example niya. Okay? So meron kang uplink frequency. So magkaiba yung frequency nung cellphone mo papunta dito, and then meron kang ibang cellphone papunta dito, ibang frequency papunta dyan. Okay, so 1920 and 2110. However, sa TDD, isang frequency lang ginagamit nila. So typical example is the 3500 megahertz, which we are using in the 3G here, 5G here in the Philippines. And then separated by specific time slot. Okay, so meron siyang downlink, downlink, tapos meron siyang supplementary and then uplink. Yan. So, meron ganyan. Ano? Pwedeng ganyan ang gagawin niya. So, downlink, and then break, transition sa uplink. Isang uplink. Yan. So, kaya may makikita kayo na mga TDD na medyo mababa yung uplink dahil naka-configure siya yung frequency niya to transmit more data sa downlink. Yan. Okay. So when you look at the different frequency bands, particularly sa 5G, ito yung mga frequencies. No? So dalawa yung frequency range natin sa 5G. So meron tayong 410 megahertz to 7125 megahertz. And then sa millimeter wave is nasa 24.25 gigahertz and 52.6 gigahertz. Okay? So ito yung mga frequencies na ginagamit natin. And as you can see as well, yung mga frequencies na pwede natin gamitin sa 5G is ito rin yung mga frequency ginagamit natin sa mga legacy networks natin. Like 2G, 3G, and 4G. Anong ibig sabihin nun? Meaning, yung mga frequencies natin, we can reuse it in any types of technology. As long as supported ito globally. Para at least yung mga foreigners na pupunta dito, magagamit nila yung telepono nila, right? And then madali, no? Yung madali yung connectivity natin. Ayan. So, pwede natin gamitin. So, there is a possibility na yung 900 megahertz natin dati, pwede natin gamitin, no? For 3G or for 5G. For example, no? Let's make a typical example. Meron tayo, for example, na 900 megahertz band. So, meron ka isang lupa. Ang pangalan ng lupa mo ay 900 megahertz band. Okay? Meron kang lupa. It's a resource. Kilala yung 900 megahertz sa band 8 na pangalan. So, typical, meron ang 900 megahertz ay FDD, Frequency Division Duplex. Pag tinignan nyo ang anatomy ng 900 megahertz band, ganitong itsura niyan. So, meron kang from 880 megahertz, okay, from 880 to 915 megahertz. So that is equivalent to 25 megahertz, no? Yung lapad niyan. Yan. Okay. And then yung downlink niyan is from 950 to 815 to 880 plus 45. 920. May tama ba? So ang ano niya is 880 plus 45. Yan, 925 hanggang 960 megahertz. Yan. So, mas ano siya, no? Mas, meron kang 35 megahertz, no? Yan. So, itong dalawang to. Kanyang kalapad yung frequency mo. Pero itong 900 megahertz band na to, hindi naman to binibigay lang sa isang operator. Okay, so sa Pilipinas, makikita nyo, itong 900 megahertz is binigay sa meron kang Smart, meron kang Globe, tapos meron kang Smart. Yan. So, nandito si Smart, nandito si Globe, nandito si Smart, nandito si Globe. Yan. Hindi naman siya binibigay ng buo. Okay. So, mahaba ang ano nito, mahaba ang kasaysayan ng 900 megahertz. No? Bakit nagkaganyan? Saka natin pag-usapan. Pero in this example, ang gagawin natin is provided no, na reset yung frequency sa buong Pilipinas at nagkaroon tayo ng pagkakataon na bumili no, ng 10 megahertz na lupa. So, ang nakuha natin itong band na to. Yan. Okay? So, dahil FDD yan, dalawang band yan. So, pares yan. Hindi pwedeng, parang sapatos. Hindi pwedeng uplink lang bibilin mo. O hindi pwedeng downlink lang. So, when we compare it to sapatos, hindi pwedeng kaliwa lang bibilin mo or kanan lang. No? Dapat dalawa. So, uplink at downlink. So, once na nakabili tayo ng 10 megahertz band, so makukuha natin to. So, sa atin na nakapangalan yan. Sa atin na nakaprangkisa yan. Naka-franchise na tayo dyan. And then, ang gagawin natin, kung ang plano natin sa ating 10 megahertz band, tatanungin tayo, no? Ano kung technology ang pwede natin ipaggamitan ng 10 megahertz band na 900 megahertz? Dito, sa unang example is gagamitin natin siya as GSM. Ayan. Sa GSM or yung 2G natin, okay, sa 2G natin, ang isang channel ay katumbas ng 200 kilohertz. Ayan, 200 kilohertz. So, ang gagawin natin ay hahatiin natin itong 10 megahertz sa tig to 200 kilohertz. So, ang mangyayari, meron kang almost ilan? 50 channels? Tama ba? Meron kang 50 channels, no? Ayan. So, meron kang 50 na channels. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 50. Okay? So, meron kang 50 channels. So, ang ginagawa natin sa mga channels na yan, ina-assign pa natin yan. Pang broadcast channel at pang traffic channel. So, saka natin pag-uusapan ano yung broadcast channel at traffic channels. Pero, ang gusto natin malaman dito is, papaano mo gagamitin yung frequency. Okay, para at least alam mo na, hindi lang pala 900 yun. Hinahati pa pala ng mga operator yan para sa specific channel at technology. Okay? So, meron kang broadcast channel, meron kang traffic channel. So, basically, yung broadcast channel, ito yung nakikita mong signal sa telepono mo. And then, kapag ka tumawag ka, ita-transfer ka niya sa traffic channel. Yeah. So, ganun yung pinaka-basic ng gamit ng mga frequencies. And then, lumipas ang panahon, nakita mo na nag improve yung mga telepono ng mga tao. And then, mahina na masyado yung hindi na sila masyadong nagtatawag sa telepono. And then, mas nakita mo sa study na mas maganda yata kung gagamitin natin for data. No, hindi lang sa voice yung pagtawag ng frequency, yung paggamit ng frequency. Kaya nag-upgrade ang mga operator into higher technology like 3G. So sa 3G, ang ginagawa natin, kailangan pa rin natin ng frequency. So ang minimum frequency na kailangan natin sa 3G is 5 megahertz. Yan, 5 megahertz. So yung 5 megahertz na yan is katumbas niyan is nasa ilang channel. So 5 divided by 0.2, 25 channels ang kailangan natin. 25 channels. So in 25 channels na yan, pwedeng ito hanggang dito. Yan, kalahati. So ang gagawin natin, itong 25 na to, kailangan natin itong i-reallocate sa 3G. Yan. So ang ginagawa natin dyan, pinapatay natin yan. Ito, hanggang dito pala. Yan. Pinapatay natin yung mga frequencies na yan, tinatanggal natin dyan, tapos i-reallocate natin sa 3G. Yan. So, nangyari, naubos na yung frequency mo sa 2G, no? So, meron ka na lang 25 dito. 25 na lang, dating previous na 50. So, ito naman ngayon, mas malaki na siya, no? Mas malaki yung data capability nito. So, yung lupa mo na 900 megahertz, dalawa na yung nakatanim. Dati, meron ka lang GSM. Ngayon, meron ka ng GSM at meron ka ng UMTS. 50-50, no? Pinati mo yung lupa mo sa dalawa. 50% sa 3G, 50% sa 2G. Okay, so ganyan ang ginagawa natin sa 900 megahertz. And then, there will come a time na kinakailangan natin na talagang mag-upgrade further na masyadong mababa na talaga yung kita sa sa 2G, no, or sa 3G. Mas maganda yung frequency natin, mas pakinabangan natin ang husto. Instead na magtanim tayo sa lupa natin ng palay or magtanim tayo ng kamote or magtanim tayo ng mais, patayuan na lang natin ng apartment. Ganun, no? Ganun ang ginawa natin sa lupa natin, ano? So, ganun ang frequency, no? So, meron siyang iba't ibang purpose, iba't ibang usage. Depende sa kung ano yung magbibigay sa kanya ng highest return, no? Doon sa investment ng operator. Ang tawag natin sa technique na yan ay frequency refarming. Okay, nire-refarm natin. So, dati, puro GSM yan. Ngayon, ginagamit mo na siya for UMTS and LTE. Wala nang GSM. Wala na yung GSM 900, no? So, isa yan sa mga strategy na pwedeng gawin ng mga operator. And then, there will come a time na nag-upgrade na yung mga technology. Pumupunta na sila sa 5G. So, there's a possibility na itong mga frequency na to, okay, itong mga frequency na yan, maging 5G in the future. Okay, so wala ng 2G, 3G, 4G. So, gagamitin na siya for 5G. So, pwede ka na mag-NR frequency sa 10 megahertz. Okay? So, gano'n ang konsepto ng frequency refarming. Kaya kung mag-i-implement ka man ng Open RAN sa LTE or sa 5G, tatanungin ka, meron ka bang frequency? And then, anong technology yung paggagamitan mo ng frequency? LTE ba o 5G? So, at least meron na tayong idea paano nila ginagawa, no? Yung frequency refarming. Okay? Kapagka tinignan naman natin ang N77 or N78, yung mga frequency band sa ano, no, ito sa 5G ngayon. So kung magde-deploy tayo ng 5G na Open RAN, so most likely dito rin tayo babagsak. So yung N77 is 3.3 hanggang 4.2, N78 is 3.3 hanggang 3.8, overlapping yan pero parehas lang yan. N79 is 4.4 hanggang 5. Okay. So ngayon, ang N77 at N78 sa Pilipinas, ito yung pinaka-band niya, no? So 3.3 hanggang 3.6. So makikita mo meron na yung color coding. Ibig sabihin ng color coding, naibigay na yan sa mga operator. Okay? So merong isang operator, okay? So 300 MHz yung buong yan. So ito yung hatian, ano? So meron kang operator 3 na merong 100 megahertz at 40 megahertz. So total meron siyang 140 megahertz. No, marami siyang frequency sa 3.3. At meron naman tayong mga operator na 60 megahertz lang. 60 lang, no? Yan, so dalawa sila, no? So parang orange yan, tapos isa kulay blue na operator. Yan. Ito naman is ito yung bagong operator na binigyan ng ano, malaking frequency, no? Tapos may isa pang operator na gusto nilang pumasok, pero makikita mo yung frequency nila sa 3.5 is 20 megahertz lang. Okay? Ito rin, 20 megahertz lang. No? So, kung makikipagsabayan sila ng capacity dyan, itong dalawa na to, 60-60, nakita nyo naman yung performance sa 60 kanina, di ba? So, kung 60 megahertz yan, so may capability yan na up to 1 gigabit per second. Di ba? Kaya niya magbigay ng 1 gigabit per second. Itong 100 megahertz, ito, may capability ito na 2 gigabit per second. Pero ang question, gagamitin ko ba siya talaga for 5G lang? Or hatiin ko siya? O gawin kong 60 megahertz sa 5G, tapos 40 megahertz sa LTE. Basta ako carrier aggregation. No? Pwede niyang gawin ganun ng ganun. Ano? Kasi kung gusto niyo lang naman makipag head to head, 1 gigabit, 1 gigabit lang tayo. Or kung gusto kong medyo maging one step ahead, so pwede kong i-push hanggang 2 gigabit per second. No? Yan. So, ito yung mga distribution. So, hindi lahat yan binibigay lang sa isang operator. Okay? So, ganyan ang distribution ng N78 at N79 sa ano sa Pilipinas. Okay? Ayan. So, next is tingnan natin yung low band distribution. Sa low band distribution, makikita nyo, pag sinabi nating low band, meron tayong 450 megahertz. So, ang currently na nandito ay si Broadband Everywhere. So, meron siyang 20 megahertz, no? Si Broadband Everywhere. So, this is based on 2018. So, baka meron na itong bago, no? Kasi this is based on lumang frequency allocation. Eh. Pero kung nakikita nyo na existing pa rin yung mga operator na yan, most likely sila pa rin na may-ari. No? Pero we need to update this band allocation. So, sa 450, nag-iisa si Broadband Everywhere. So, ginagamit nila yan for LTE, 450. And then we have this frequency allocation for 700 megahertz. Yan. Dati itong 700 megahertz is pag-aari ito ni San Miguel Corporation, but unfortunately hindi sila natuloy. Kaya pinaghatian ng tatlong operator yan. 17.5 megahertz na bigay kay Smart, 17.5 megahertz kay Globe, at 10 megahertz kay Mislatel. So si Mislatel is dito. Yan. So meron kang, ilan to? 17.5, that is 35 plus 10, that is 45. No? 45 megahertz. Yan. Yung 700. Pero ito yung tatlo. So kung merong operator na papasok ulit, sasabihin nila sa 700, wala na. No, wala nang frequency. Okay? Ito kagandahan no, kasi makikita mo sino yung may pinakamaraming frequencies. Sa 850, nag-iisa si Smart diyan. So merong 850 diyan. Frequency allocation. At sa 900, si Smart at si Globe. Yan. So andito si Smart, andito si Globe. So mas marami si Globe na frequency. Kasi dati yung frequency ni Globe is pag-aari ni Islacom. And then nung inacquire ni Globe si Islacom, napunta rin sa kanya yung frequency. Kaya ang laki ng frequency ni Globe sa 900 MHz. So makita nyo, sa 900 MHz, itong dalawang operator ay meron talaga silang advantage. No? Kasi marami silang frequency to cover long range. Okay? Si Mislatel is may 700 pero 10 MHz lang. No? Pero maliit lang yan, yung 10 MHz. Pero sufficient na. Next is yung high band. So when we say high band, ito yung mga 1.8. So sa 1.8 gig, nandyan si Smart at si Globe. Okay, so 60% kay Smart at 40% kay Globe. Yung 1900 for TDD, apat silang nandyan. So it's 10 megahertz band. Tatlo lang, no? So si Smart merong 2.5, si Globe may 2.5, at merong isang company ang pangalan is si Multimedia Telephonic Incorporated. I'm not sure kung anong business. And then meron pang 2.5 na not assigned. So merong good news, no? So kung kayo ay magtatayo ng isang operator, pwede niyong i-ano pa yan. Meron pang 2.5 megahertz. Pero maliit yung bandwidth. 2.5 megahertz lang. Maliit pa yun sa isang 5G carrier. Okay, so wala pa nga yan. Zamri, nakataas ka ng kamay? Question? May question ka ba? Yan. So kung may question, just type in sa chat box if you want also to speak. Yan. Okay. So ito yung frequency allocation, and then sa 2010, merong nag-isa si dito. Meron siyang 15 megahertz yan sa 2010. And then sa 2100, yan. Sa 2100 is si Globe may 10 megahertz, si Mislatel may 15, si Smart ay may 25 megahertz. Malaki yung band ni Smart dito. And merong isang 10 megahertz na under litigation, Supreme Court litigation. So, hindi ko lang alam kung, I'm not sure kung kung naibigay na to sa ibang operator. Okay, kung naibigay kay Mislatel or kay Globe or kay Smart. Pero in the past years, under litigation yan. So, hindi pa nila alam kung kanino ibibigay. Okay, so probably for another operator coming in. Okay, so yan yung high band natin. Another sa high band is yung 2300. Okay, so maraming frequency rin si Smart. So this is TDD band. So 60 megahertz kay Smart, 10 megahertz kay Globe, 30 megahertz kay Globe, and then meron pa isa not assigned. No, may 10 megahertz pang not assigned. So meron pa tayong pagkakataon. Frequency allocation sa 2500. Okay, so merong Smart. Kung narinig nyo na si Altimax, you can research more about Altimax. Sino si Altimax? Si Globe may 60 MHz, and then si Mislatel is 20. And meron na namang 5 MHz na not assigned. So kung susumahin natin, merong 5, merong 10, so may 15 na, merong 10, may 25, so may 27.5 MHz na free. No? So pwede ka pang magtayo ng isang, kaso ba maliit lang 'yun, 25. Wala pang umabot ng 30 megahertz, no? So makita mo kung may bagong paparating, medyo medyo may ano sila dun sa pinaka mga legacy frequencies. Si Miss Latel is nasa 33. And then yung 3.4, ganito yung allocation. So nakita niyo na si ano. Nakita niyo na yung 100, 100, tsaka 40. So sino yung 60 kanina? Si Now Telecom meron 20 megahertz. Si Broadband Everywhere may 20 megahertz. I'm not sure kung anong plano ni Now, kung anong frequency gagamitin niya no sa ano. Baka meron siya sa higher frequencies na wala dito sa listahan natin. Kasi these are the legacy frequencies eh. Meron pang bagong mga frequencies na inallocate for telecom, which is the millimeter wave. So malaki 'yon. Pero ang pinaka ano ng millimeter wave is um limited yung coverage niya, no? Maliit yung coverage niyan. Okay. And pagka tinignan mo yung buo, ito pala is sa 2020, no? Yan. So ito yung buo na frequency allocation. So pinakamarami pa rin si Smart sa frequency band na to. 36, hindi pa kasama yung millimeter wave, no? 36% si Smart, si Globe is 27, and then 23% si dito. Broadband Everywhere, merong 5%. Si Altimax, merong 4%. Si Now Telecom, meron siyang 2%. Si Multimedia Telephony is nasa, hindi naman zero, no? Nasa point something, but less than 1%. Under litigation is 1%, pero unassigned na 2%. Ito yun. Ito yung 2%. So, makukuha yan ng mga ibang operator, there's a possibility na na dumami pa yung frequencies nila. Okay. Ayan. So, ano ba yung bandwidth, no? So, when we talk about bandwidth, kanina ko pa sinasabi yung bandwidth, no? So, yung bandwidth is an information signal. The bandwidth of an information signal is the difference between the highest and lowest frequencies contained in the information. Okay, so pagka tinignan mo sa spectrum analyzer yan, ito yung bandwidth, no? So, dito natin tinatransmit sa loob nito yung ating data mula cell site pababa ng cellphone at cellphone papataas ng cell site. So, pagka tinignan mo sa spectrum analyzer yon, ito yung pinaka-channel na nakikita natin, 2100. So, ito yung mga channels ng mga operators. Tapos, nandito yung uplink, nandito yung downlink. So, ito, these are allocated sa ibang technology. Probably point-to-point, no? Pero they're not part of the broadband wireless access technology. So meron bang LTE signal? Ito yung type of LTE. Kapag tinignan nyo sa spectrum analyzer, ganitong itsura ng isang LTE signal. And the same time is 5G. No? Parehas lang sila halos ng 5G signal dito sa dito sa spectrum analyzer. So meron pang bandwidth. So ang bandwidth nito ngayon is nasa 10 megahertz. Okay? So 10 megahertz ang bandwidth niya. Okay? So, ganyan nakikita yung kanyang, ganyan ang itsura ng isang LTE frequency. No? Kapag tinignan mo sa spectrum analyzer. So, ano bang spectrum analyzer? No? Nakakita na ba kayo ng spectrum analyzer? Ang spectrum analyzer is an electronic device, katulad niyan, that displays yung signal amplitude. Okay? Signal amplitude as it varies by the frequency. Yan. So, ito yung dalawang klase, no? Ng spectrum analyzer. So, the frequency appears on the horizontal axis and then yung amplitude is displayed on the vertical axis. So, ganyan yung pag-check. Kaya nakikita ng mga operator kung may gumagamit ng kanilang frequency or wala. Okay, kasi ano yan, they can check no yung mga frequencies even though invisible sa naked eye. Okay? Ayan. So ito yung ating ito yung ating um, um, devices to check na yung mga frequencies na ginagamit ng ating mga operators. So now we will proceed with the motivations of spectrum sharing. Why operators are doing the spectrum sharing. So as I mentioned earlier, yung spectrum is one of the important resource no sa ano ng sa mga operators. And if you do an analogy of the spectrum, it's considered as like highways or mga kalsada natin ano. Highways or super highways no. So there's a possibility na merong mga part ng spectrum natin na highly congested, like for example these are LTEs and these are 5Gs. So we want to make it dynamic, no? How to make it dynamic, no? So the motivations of the spectrum sharing are as follows, no? So 5G can operate on low, mid, and high band spectrum for different coverage capacity and usage scenarios. So we have different types of spectrum na ginagamit for 5G. And the 4G or LTE uses mid-band spectrum. And if you acquire a new spectrum, the cost is very high. Okay, so medyo may kamahalan yung spectrum users fee. No? And then you can acquire early advantage of 5G radio, which is 3 times the spectrum efficient than LTE. So if you use the spectrum for 5G, yung spectral efficiency is higher. So you can get more data out of your spectrum. You can transmit more. And then the opportunity to deploy 5G without refarming LTE frequencies or buying new spectrum. So you can deploy 5G nang hindi na bumibili ng bagong frequency. You can just reuse no yung or refarm yung LTE frequencies or without refarming yung LTE frequencies, and can be deployed in both SA and NSA. So the concept of dynamic spectrum sharing is this is a key technology that dynamically allocates the spectrum resources between yung LTE, 5G, NR within the same frequency band. Typical example is the 700 megahertz that is being used right now for dynamic spectrum sharing. So it's a combination of LTE and 5G. So in one baseband or radio, so you are using two technologies and same frequencies. No? So there's a specific technique na ginagamit for the DSS to apply. Pero the concept is as your subscribers increase sa 5G, it also increases the allocated frequency towards that 5G. And then kapag nagbago naman, going back to LTE. So dynamically, your system is adjusting which technology will be given more resource or frequency para ma-serve nyo yung mga subscribers nyo. Okay? So ito yung pinaka-concept ng dynamic spectrum sharing. So kaya importante ito sa 5G and also for one of the use cases din na tinitingnan for Open RAN. Okay, so isa yan sa mga use cases ng Open RAN. Okay,